Okay, good day, and we will today for our next laboratory activity we'll be discussing about correlation of experimental data. Okay, so correlation means the relationship between these two variables x and y. So if you want to establish the correlation of the dependent variable and the independent variable, we need to get or establish a certain parameter that would tell us whether they are they have a relationship or they have correlation with each other. Okay, say for example in this graph. Okay, so it is normal that the datas will have variation or scatter. Okay, it is brought about by the random errors, no, in almost all instruments. Almost all instruments have errors, so therefore cannot expect that we can get a single value, okay, every time that we get data. So with that, how do we establish whether there is a relationship between the dependent variables and the independent variables? So in this example, you can clearly see that there is a strong relationship. There is a linear relationship between x and y. So as x increases, the y value also increases. How about this one? Can we say that there's a relationship between x and y? Maybe we can conclude that there is no relation. The variables is just random. No, cannot establish whether there is a relation between x and y. How about this one? For this graph, we're not sure. We are uncertain whether is there a relationship, is there a linear relationship, or it's just the same as b. So therefore, we need to establish a parameter that will tell us whether there is a strong relationship between x and y. So that parameter is what you call the correlation coefficient. Okay, correlation coefficient. So it is denoted by this variable r sub xy. Okay, so if you have two variables x and y, so you just follow this formula. So something a formula. First you get the mean. Okay, kaning x bar is the mean of the x values and y bar is the mean of the y values. Okay, so just follow this formula. Summation of the product between the x variable minus the mean and the y variable minus the mean of y divided by the squares of these parameters. Okay, so after nimo ma-plug in yung mga values ani, makakuha ka og correlation coefficient. Now, you have a table here, minimum values of the correlation coefficient for alpha or the level of significance. Okay, so may pasabot ani nga values. So meaning kung naa kay n samples or 3 samples, and then you have your significance level is 5%. So kani 0.05. No? 0.05. So meaning kung 3 samples lang, yun ni dapat ang R nga makuha nimo dere or correlation coefficient must be greater than or equal to 0.997 in order for you to conclude that there's a strong correlation between x and y variable. So makita nimo no, as you increase the number of samples, kagamay po ang iyang correlation coefficient nga needed. Okay? So in order to illustrate that one, let's have an example. So this example is between the lap time and ambient temperature. Now, is there a relationship between lap time and ambient temperature? So ang lap time is, it is thought that lap times for a race car depend on the ambient temperature. So na ay hypothesis nga ang ambient temperature ko no maka-affect sa lap time or ang time nga ma-finish sa car ang isa ka track, okay, or a certain track, okay. So the following data, so pila ka data lang ikuha, 1 2 3 4 6 datas lang, oh. Following data for the same car with the same driver were measured at different races. So kung 6 number of samples, and then sa may gayon niya dere, thus a linear relationship exists between these two variables. Yun siya, naabay relationship ang lap time o ambient temperature. So unsay gigamit niya nga 95% confidence level or alpha nga 0.05. So, tanaw na to sa table, 6 ka sample and 0.05 nga alpha, you need 0.811 correlation coefficient. Dapat daw greater than 0.811 or greater than or equal to. Kung below ani, you conclude that there is no correlation. If greater ani, conclude ka there is correlation between the two. Okay, so ang gibuhat niya is gi-graph. Mo ni ang graph. So dili kay maklaro, no? So next is you compute agatong sa imo ang mga needed sa imo ang correlation coefficient. So just follow this one, no? Then i-plug in at nimo dire, you'll get 0.4013. So unsay conclude nimo ni? So for a 9%, 95% confidence level, alpha is 0.05. For 6 pairs of data, we obtain a correlation from the table of 0.811. Since R sub xy kanina compute nimo is less than R sub t, we conclude that the apparent trend in the data is probably caused by pure chance. Okay, so meaning there is no correlation between lap time and the ambient temperature. Okay? Murag layo ra pud kayo, no? So, okay. Let's proceed with the least squares linear fit. So, this is our second laboratory activity. Okay, so given ka og set of datas, how do you fit a curve ani nga data, no? So, the way you do that is by using this method of least squares. So, example na to ay kaning linear atong example. Okay? But of course, kaning nga method, ang pagkuha sa formula is the same for second order or third order nga polynomial. Okay, so example, kung natay Excel. Okay, kung natay Excel, natay X, natay Y. 1, 2. Okay. 2, 4. Okay. So, kung gusto na to kuhaon ang graph ani sa atong buhaton, ano to, insert scatter plot. Okay? Okay. Linear kaya pwede. Muna natin yung 5. Para di kayo klaro. Okay. Ani. Say for example kani. So, trend line. Okay, linear. Okay. Saan mo na ito pagpakita ang equation ani. Grid line legend. Ano makan ako? Clear. Set. Dara. Ano ba to? Need, ay. Tara. Okay. Okay. Ay. Muda ako. Okay. Ako. Mo ni ang equation sa imo ang kani sa imo ang graph nimo. Question is, yun sa may pag-compute sa Excel, no? Yun sa may pag-compute sa Excel, nakuha siya ning equation. Say for example, isda nato ni og polynomial second order. Change pod no third order. Ay, wow. Change sa third order. Oh. Change. Giyon sa man ipagkuha sa Excel kani nga equation. So mo na yung ato ang buhaton karon, no? Okay, so going back. Ay, post na. Okay, going back. Let's have this linear lang sa kaning linear. Balik na to linear. Okay. So we would like to obtain values of constants A and B, or in other words, kung mag-experiment ka, di ba, naamang kay x, naamang kay variable nga gikuha. Sample, i-measure nimo ang voltage or current baka, current no, consumption, current. Then ang power versus power sa kanang lahi nga load, no? Sample lahi nga load imong kwan, lahi nga bulb baka diha. So nakay mga data. Kay mga data diha. So the question is, how do we fit, or what is the equation that would describe this data? What is the equation that would describe this data? Mo na ito ang question. So ang gamito nato ana para makuha nato ning nga curve or line that would represent this data, kay ang purpose ani nganong kinahanglan po nato ning equation. Kay kung ma-establish nimo ang equation ani, you don't need to experiment na, di ba? Kung makuha na nimo ang equation, no, kay ang kana nga equation that would represent the phenomena, no? So ang button na to na is we use this least squares or linear regression, no? So we want to determine the best fit to the data. So kanina term of best fit. So there are many methods, no, pagkuha ning best fit. Isa na is imo ang matamatahon na magsulat ka og gamit ka og ruler ana nimo mata-matahon nimo. Ana baka pero problem na you're not sure. So that is why we will use this least squares. So unsa ni pagkuha ng least squares? Kay katong mga equation kaganin na least square man ang gamit adto or linear regression man gamit ato. Kani nga equation no, linear regression na siya. Okay. Least square. So kung kani ang equation nga kani ang equation ani nga line y equals ax plus b kay linear man eh. So naa kay error karon, no? Kay siyempre dili magid 100% nga ma-fit sa imo ang curve ang kani nga data. So naay difference ang value sa y computed og y nga data nimo kani man ang value sa imong y. Kaning value of y nga dako mo ni computed sa imong equation. So naay difference. So mo nang ang difference ana mo nang error. Kaning e sub I. Okay, so ang the square of the error kung square nimo ni usually diba gagmay ra man ning error kung square na nimo mas mugamay pag yun na siya. So mo na dai ni square mo ning error mo na dai ni metabo. Okay, imo ning i-substitute unsa man ang value aning y nga dako kani x plus b. Square dai nimo ni. And the summation aning squared errors for all data points is represented by this capital letter E. Okay, capital letter E. So we now chose A and B. So siyempre, 'di ba, ang best fit ani nga equation, ang best fit ani nga data is kana yung gamay nga error, 'di ba? That would result to small error. Mo man na ato ang objective. So we want to minimize this value. Kani nga value kani. So unsa naman yung pag-minimize? Mo na siyang differentiate with respect sa variable. Kay kani nga mga variable mo ni ang maghatag og equation nga that would result to a least error, no? Minimize nga error. So kung minimize error, di mo na ang best fit para ana nga data. So mo na din siya. Partial of E with respect to A. Constant ang A. So kung constant ang A, sa metabo ani mahimo na din 2 times kani nga quantity times constant man ang with respect to A man, ang A man ang mong variable. So times treat mo ning x as variable, so mo nang times xi kani dire. Ang kung with respect to B, so kani ra gyapon 2 times axi plus b minus yi nya. B wala may variable. So 1 na rin times 1. So mo ni siya. And then so naa kay kani imo nang equate to 0. So naka equation na kani. So unsa kanimo pagkuha ang value sa A o B ana? You use Cramer's rule, no? Imo nang i-review ang Cramer's rule. So pagkuha na nimo no using Cramer's rule, makuha nimo ng equation. Again, i-solve ninyo niha using Cramer's rule kung makuha ninyo ng equation. Kani. O kani mo na dahil ni. Na dahil kay least square best fit to the data. Makuha na dahil mo ng equation kani. And as I've said kani, kung mo ni ang data nimo kani siya gikan ni siya sa least square. So kung gusto niyo i-solve ninyo ni kung mao ba ni makuha nga answer, you can do so. Okay, and then ang r squared kaning r squared nga kani r squared mo ni ang coefficient of determination. So magkadako gali ning r squared nimo, the best fit line accounts for most of the bread. For engineering data, R squared will normally be quite high, 0.8 to 0.9 or higher. A low value might indicate that there exists some important variable that was not considered. Okay, so dapat dako ang value aning R squared nimo, no? Dol-dol gani sa 1, Meaning na good fit na siya. Okay? Also, you have the standard error of estimate. Kani. So, unsa man ni siya? Imurang minus ang summation sa y divided by n minus 2. We'll get this standard error of estimate. So, standard error of estimate. Okay, say for example, the following table represents the output of a linear variable differential transformer. LVDT, an electric output device used for measuring display for 5 inputs. So, unom ka data. So, kaning LVDT manggod, pang measure ni siya og length ni mo no. So, ang output nga makuha nimo ani is volts, din ana say corresponding length. So, ang imong problem is determine the best linear fit to this data. Draw the data on a BL plot and calculate the standard error estimate as well as coefficient of determination. Okay, so to solve this problem, okay, so kuhaon nimo ang A ug B. O pag makuha na nimo A ug B, na naka-equation mo na rin ang best fit sa diri nga data. Anyway, sayon na kayo ni. We can now compute the coefficient of determination and the standard error. Okay, so ang standard error niya is muna yung coefficient of determination 0.999. So dual kaayo sa 1. So this is high, close to unity, consistent with the plots. So makita po niyo sa plot, best fit gini nga line. And the standard error of estimate is 0.0278. Okay? So that's it. So muna inyong buhaton. Okay, for your laboratory number 2. Okay, laboratory activity number 2. Okay, so your objective is to determine the curve that or determine the correlation between a certain variable and blank lang nato ni kay depende man sa activity niyo buhaton. Okay, to determine the coefficient of determination and standard error of estimate. Okay, kanaron daw No, so the title would be the correlation between okay. So, unsa ni siya? What you're going to do, sample ng example. Example. Dependent variable. Dependent variable. Current. Bali. Independent variable. Dependent variable. Power. Okay? Sample, gani. Kung gusto nimo ni ko ang relationship aning duha, so sa ibaton nimo, pwede ka mag pwede ka ani na kay na kay battery or power supply, no? Tanong nato ni power supply. Power supply. Na kay bilya diri. Light bulb. Tara. Sa pa. Pwede ka nga set up, no? Pwede nga kanina set up. Lahi-lahi o ninyo ni wattage ani. Example rin ha. Pero pwede mong buhat og lain. Measure the current and voltage at different light bulb power rating. Okay, so lahi-lahi nga light bulb, no? Gamay nga light bulb, dako, magkadako. Lahi po nag power. So makuha na din yung mga relationship between current and power, no? So pwede din ani. Or anything na gusto niyong mahunahunaan. Pwede. Okay? Okay. Pwede ninyo i-check unsay correlation sa abay correlation na ano kung kadako imong kaon, makadako ba imong score. Pwede na, depende ninyo. Okay, so that's it. So follow gyapon the same format. Okay, any questions, just chat sa group Discord.